Java has, from the beginning, had an extensive facility for handling exceptional circumstances. As with everything else in Java, it's an object-oriented system, so they have classes for exceptions. Now, interestingly enough, the exception class itself doesn't have much in it. Here is the Java API, and the parent class of exception is throwable. Throwable has two direct known subclasses, exception and error. Errors are conditions that are never supposed to happen, that are supposed to cause your system to fail, so that you don't normally catch those. And when we look at our try-catch blocks, that's something you don't want to catch, which is also why you don't normally catch error or even throwable. So at any rate, if I look in the methods in throwable, first of all, there's a series of constructors. There's the default constructor and the one that takes a string, and one used for chaining them together so that you could have a throwable with a message and a throwable as a cause as well as a throwable with a cause without a message in it. And if I look at the methods here, the methods that are very, very common are like getMessage, print stack trace, and there's a toString method as well. Now if I go look at the children, if I go look at exception as a child class, you will see that they have the same constructors, easy enough, so they can all call super. But if you look at the methods, there aren't any. All the methods that exist in exception are those that are inherited from throwable. Now there are many, many, many subclasses of exception. These are just the direct known subclasses. They have a whole range here. If I also take a look briefly at error, you will see that errors are things that can be serious problems, like virtual machine error or coder malfunction error, which always sounds interesting, or my favorite, thread death. Generally by starvation as well, something we'll come back to when we talk about concurrency. At any rate, looking at exception, if you look at its normal subclasses, there's a whole bunch of them, but there's one that is special, and that direct subclass that's special is the one called runtime exception. Now this, unfortunately, is a lousy name because all exceptions occur at runtime. I mean, if they were errors, they'd be compiler errors. This is a runtime exception that is significant because it's the superclass of exceptions that are unchecked. In fact, I would have been happier if they had named this class unchecked exception, because what an unchecked exception is, it's an exception that does not require a try-catch block or a throws clause in the method signature. So all exceptions that do not require that are ultimately descendants of runtime exception. And all other exceptions, things that are direct descendants of exception or one of the other subclasses, are checked, and they do require a try-catch block or a throws clause. Now taking a look at a very simple case here, I've got a little class called arithmetic with a main method in it, and you see I have a pair of integers and then I divide them to get a double and print out the results. And if I run this, it's very simple. All I see is x, y, and z, and that's fine. So the question is, what happens if I divide by 0? Now you'll notice I did not need a try-catch block, but I am going to get an exception. In fact, the exception I get is arithmetic exception, divide by 0, and it tells me where as well. This is the default stack trace showing me what happened and where, and it's composed of multiple pieces. It has the name of the exception, it has a message on it, divide by 0, and then it's got the trace showing the line where the exception occurred, as well as many, many other calls. In this case, everything's very, very simple, but in general, these are going to be a lot more complicated. Now, arithmetic exception is clearly a subclass of runtime exception because the compiler did not force me to put in a try-catch block or a throws clause. Now, before I go and start doing variations of this, let me put in a try-catch, and what I'll do is I will do my surround with, I think I have to do it this way, surround with a try-catch, and it assumed that we were going to catch exception. Let me make it arithmetic exception, because I know specifically that's what it is, and then again I'm going to see the stack trace. Now, by the way, we have a little bit of a race condition going on here. It's not a big deal, but the exceptions are getting printed to standard error. The print line here is getting printed to standard out. Both are the console, and which one of these gets printed first is merely a matter of chance. So that's, again, what they call a race condition. Now that's the print stack trace, the same thing we saw before. Here, on the other hand, would be the get message. So if I say, let's go to standard error of e.getMessage, then you see there's just the divide by 0 part. And finally, if I just print E, I'm invoking the toString method. And in this case, the toString method is the name of the exception and a colon followed by the message itself. Normally, I'll simply print the stack trace, but there's the whole thing. Notice that, of course, because we caught the exception, the line after it does in fact get executed. So we both are catching the exception and reporting on it and continuing along. If we didn't want to continue, we could simply put inside here as simple as a return statement. And what would happen then is that main would shut down gracefully after printing out the exception. You can always do system.exit with a return code, but that's kind of a harsh, abrupt ending, whereas a simple return from main is a so-called graceful shutdown. So there is an unchecked exception using a try-catch block to do it. Now, if I want to see what a try-catch block looks like when I have multiple possible exceptions, let me use reflection. So I'm going to take the current class, arithmetic, and get its class reference. Every class has a reference of type capital C class, accessed using its lowercase c class property. And in the class, if you will, there's a method called newInstance. This will instantiate a class as long as it has a default constructor in it. Otherwise, I have to get the constructor reference and start working with it directly. This is an example of reflection. Now I'm getting a warning here because this can throw multiple exceptions, so that when I surround with a try-catch block this time, you'll see that I can throw an instantiation exception or an illegal access exception, either one or both. Now, this is how the code would look in Java 6 and below. Java 7 introduced the so-called multi-catch, and to use that, all I have to do is to separate the two exception types with a vertical bar, and then I can do the same process for both of those types of exceptions, which is a very nice convenience. It's something a lot of Java developers don't realize is there. So if you're throwing exceptions that are in an inheritance relationship, like if I caught file not found exception and IO exception, then this is not allowed. The exceptions have to be separate. They can't be related by inheritance. Otherwise, you do the two separate catch blocks or simply just do the parent IO exception. But in this case, they are siblings, and therefore I'm able to use the multi-catch mechanism. So that's all a nice little usage of the multi-catch example. Now, there's another new feature that was introduced in Java 7, and that's the so-called try with resources mechanism. With try with resources, you're trying to get around the try finally issue that comes up with try-catch blocks. Now, up until Java 7, whenever you had a try block, you either had to have a catch block or a finally block or both, and you could have multiple catch blocks followed by a finally. And one possible use of this is to say, all right, let's say I want to read the lines out of the file and then write them to some other file or just print them to a screen or something like that. Now, we're going to talk more about the new I/O stuff later, but here's an example. There is a class called paths with an S, and that has a get method that allows you to chain together a path name that in a platform independent manner. So for example, I happen to be in the root of this project. If I said look inside source main Java exceptions and the statement and now assign that to a local variable, that is my current directory. Now that's an abstract path name. You notice there's no exception or anything like that. If that doesn't exist, well, so be it. It's not a particular problem. And in the I/O section, we'll talk about how to create directories and create files and all the other things you might want to do with it. But say I simply want to read this single source code, this arithmetic.java class, and write it to the console. Well, if I start with that directory, then there is the buffered reader mechanism would allow me to say, let's do a buffered reader. BR is a new buffered reader, which takes a new file reader. Actually, let me use the new I/O mechanism, which would be to say files dot new buffered reader here. And in the new buffered reader argument, they want a path. Now I have the directory, and then I could say resolve, and then here's the name of the class in that directory. And there you have it, and I've achieved a buffered reader. The problem is that now I have exceptions to deal with again. Now I could surround it with a try-catch, and I'll do that. And you see there, in fact, now I have my buffered reader with the try-catch block. And that's all fine. But what I'd like to show is another issue, because here what I would have to do after doing whatever I did with it, like if I said br.readline, say I only wanted to read the very first line, and then print it out. So let me do all that in one combination, br.readline. Then what I'd also like to do is to make sure that the file is closed. Now, unfortunately here, I don't have the access to br because it's a local variable inside the try block. So then I have to go to the trouble of putting in buffered reader br equals null, and then assigning it inside the try block. And then, of course, in the finally block, I have to say if br is not null. And unfortunately, the close method also throws an I/O exception, and therefore I have to wrap that as well. And you can see now why Java I/O gets to be very, very ugly very quickly. Fortunately, there's a new system inside of Java 7 called try with resources. So what I can do now is I could say, actually, let's do the try with resources here. And in that case, what I'm going to do is I'm going to put in parentheses after the try block the buffered reader instantiation. So let me grab that and paste it here. Don't need that line anymore. And I will grab the rest of this and put it inside. And now I don't need the finally block at all, because what will happen now is that the buffered reader will be automatically closed because I opened it in these parentheses in the try block. The rule is that any class that implements the so-called auto-closable interface, which simply provides a close method. So any class that has a close method that you make sure implements auto-closable can be open this way, and then what will happen is that when the resource has completed, then it will in fact get closed automatically. And when I run this now, if I just wanted to print, run this again, of course I'm just printing the first line. There's the package statement on this file, and you can see how that worked very nicely. Now the finally block is very important. I skipped over that a little bit. Let me just make a comment about it here. I have a try catch. If I add a finally, the purpose of the finally block is to execute this gets called in any case. So now I've added the finally block to the try catch block that throws the arithmetic exception. So if I run the code again, you'll see that this gets called in any case got called. Notice the race condition. This time the exception got printed after that. But either way, it got invoked. And the finally block code will get executed whether you throw an exception or not. Now in this case, it looks like there's a sequential operation here that I try and threw an exception and caught it and printed it and then did finally. But the thing is remember, this is a runtime exception. I can even get rid of the catch block, and the finally block will still get executed. It's just that this time, when the finally happens, or after finally is executed, then the code goes searching for a handler for the exception. And that, of course, there isn't one in this case, and therefore the main method will fail. Let me put that back in. But if I put this in such a way, if I change the input value so that I don't throw the exception, everything still works, and we have the rest of it as well. So this is an example of using try and finally, or try catch and finally, or you can have try catch 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 and finally. See here I have a multi-catch here. I could add a finally block to that if I wanted to. This is the try with resources mechanism. Again, the only requirement is that the instance that you're working with has to implement auto-closable, and buffered reader does. So does, for example, statement out of JDBC, which we'll take a look at later as well. And the final issue I wanted to mention regarding exceptions is how to create your own exception class. So if I want to make an exception class, the hard decision is what class do I extend? Do I make it extend exception, or do I make it extend runtime exception? In other words, do I make this checked or unchecked? And if I call this, say, my exception, and it is traditional to end in the word exception, then I'll put in the extends, and now I do want it to extend one of those classes because only throwable things can be thrown, if you will. Only things that extend throwable can ultimately be thrown in a class and then caught as well. So in this case, I'll extend exception, and frankly, that's enough. Now I have a perfectly valid exception class. The problem is it has no message in it. There's no message anywhere here, and that's going to be a bit annoying, actually. So if I go back to my demo here and I just said throw new my exception. Now, first of all, I have an issue because I haven't declared that my method can throw that. So I'll wrap it in a try catch block again. And if I do a print stack trace here, then you see it does say exceptions my exception, but you notice there's no message built into it. So that if I was to try this instead, if I was to say, let's do the print to standard error, e.getMessage, I get nothing, or rather I got null, which is probably just as bad, if not worse. So when I make exception classes, what I like to do is I like to put in a couple of constructors. First of all, I like to put in the constructor that takes the message, so that if I supply a message, then it will invoke super. It'll call the superclass constructor for exception and save the message at that level. And now if I provide a message, it will be available, so that in here, if I said let's throw an exception with this is my issue or something like that, when I run again, now I actually have the message. But I'd still like to be able to have something when I don't provide a message. I'd still like to have a default, so that what I normally do is put in an additional constructor, the default constructor, and with that one I could call super, but in this case what I like to do is use this with a default message, like that. And now if I run my program from before, I get the default message, whereas if I supply a message, I would get the message I supplied. And I like this little mechanism because it demonstrates both. And this way, there's always a default in case I need it, and yet I also have provided the constructor that allows me to put in additional messages if I want to. Now, there's no reason I couldn't add in the other constructors from the parent, the ones that have to do with causes as well. I could simply say, oh yeah, let's add in the one that takes a message and a throwable, or even all of them, and you see that it all could be added. Now they're all going to call the corresponding super here. Let me undo that and just say that purely is up to you as to which ones of those you'd like to add. Now finally, I want to make one additional comment. Checked versus unchecked exceptions have been controversial in Java from the very beginning. Java was not designed for experts, believe it or not. It was designed for relative beginners. C++ required you to have expertise in order to be productive, because C++ operates at both a very high level and at a very low level. And it was building on top of the C programming that people had experience with that was the dominant language in the industry at the time. C wound up being replaced largely by C with classes, which ultimately became C++. And then Java came along to try to eliminate a lot of the problems people ran into with C++. That's why Java added its own garbage collection, it added arrays bounds checking, it added, among other things, this checked exception capability. Unfortunately, with checked exceptions, the problem is that if method A is going to call method B, is going to call method C, is going to call method D, and D throws an exception, if I'm going to deal with it in A, then B and C also have to declare that they throw that same exception. It gets to be a very awkward programming model when you deal with checked exceptions. And consequently, some of the dominant open source programs in the industry, like Spring and Hibernate, tend to catch all checked exceptions and rethrow them as unchecked, so that you can catch them if you want to, but you don't have to. Spring will catch JDBC exception. The Spring JDBC template catches JDBC exception and rethrows it as one of their dozen data access exceptions, all of which extend runtime exception. They're all unchecked. The Java people are not necessarily happy about this because you have essentially subverted the whole idea. You've made it so that you are ignoring the whole purpose here, which is to say, philosophically, according to Oracle, according to the Java tutorial, checked exceptions are things that you can recover from, and unchecked exceptions are not. But that doesn't really hold in practice either. You're not really ever supposed to catch something and then fix it. A try-catch philosophically is supposed to be more of a diagnostic. Find out what went wrong and then repair it. Plus, some unchecked exceptions are unchecked not because you can't fix them, but because they're so pervasive you'd have to wrap your whole code in a try-catch block. I mean, look at arithmetic exception. Every division in your program would have to be wrapped in a try-catch block if that was a checked exception. Or null pointer exceptions, even worse. Every time you did reference.method or reference.property, you'd need a try-catch block. I mean, you might as well wrap the whole code in a try-catch block. And therefore, these philosophical debates go on. So I'm not going to tell you what to do. You get to pick whatever you think is appropriate for your environment. But I would say that based on what's happened in the industry, many of the open source projects written by experts have a tendency to catch checked and rethrow them as unchecked, whereas people in general will write their own checked exceptions to be specific to their particular project. So hopefully that gives you the whole sense of all the things available in the exception handling facility, and we'll deal more with those throughout the rest of this class.